Hey guys, welcome to Humanities. So this is going to be the first of a number of videos I do, and I'll be emailing them and making them available to you to be able to watch on your own or in groups. And I think they're a really good resource to be able to go back and listen to at your own speed and as a reference for study for the future. So the first one we're going to be looking at today is called Why Does the Wind Blow? So it's the start of chapter 4 from our geography textbook. Just a quick recap of what we've looked at so far this term. So we started off with looking at what is weather and the different layers of the atmosphere and 3 reasons why weather changes. And they were the air temperature, the air movement, the amount of water in the air. And that relates directly to the handout that I gave you. Then we looked at how is a natural disaster different from a natural hazard. And then more recently, we've looked at why does it flood, including the different types of flood. So the rapid onset, the slow onset, and the flash flood. And then we worked on the posters, which we finished last class, which you guys answered the question, do you think we should still be continuing to build communities, schools, hospitals on floodplains? Which is great to hear your response. So today we're looking at why does the wind blow, and it starts our section on weather and the wind. So we begin to look at wind and its impact on our lives. The Earth's atmosphere protects us from the extremes of the sun's heat and the chill of the outer space, making conditions right to support life. The air in the lowest layer of the atmosphere is called the troposphere. Weather is the result of changes in this layer of the atmosphere. Now, as I mentioned here, we looked at the different layers of the atmosphere, and we can see here that weather is the result of changes in the troposphere. So, does this look familiar? It should. It explains the different layers of our atmosphere. Now, if we were to look closest to the Earth, so that's our Earth's surface, 16 kilometres above the Earth's surface, between the Earth's surface and 16 kilometres, lies the troposphere. And that is exactly where weather occurs. So anything under there, in this space, where weather happens and most planes fly. Okay, so that's very easy to establish. Here's a question for you. Did you know that the air around us actually has weight? Might be able to feel it, but it definitely does. So the weight of the air actually pushes down on the surface of the Earth, creating pressure. Just like if you were to get your hand now and place it against your desk and push down, you're creating a pressure. Likewise, the air has pressure on our Earth's surface. The higher you go into the atmosphere, the less air there is, which means there's a lower pressure, so there's less weight. Here's a little quick fact for you. Have you ever heard of athletes doing altitude training? They do this to try and increase the amount of oxygen in their bodies. So the higher they go into the atmosphere, the higher the altitude, which means that there is less air for those people to breathe. Athletes train in these conditions to help their body create more red blood cells, which is responsible for carrying oxygen around their bodies. It's a little bit scientific, but it's an interesting fact to know. Okay, air pressure. What is air pressure all about? When a person blows up a balloon, the pressure inside the balloon is higher than the surrounding air outside the balloon. When the neck of the balloon is released, the air rushes out of the balloon. This is called wind. We know that. If we did not have wind, temperatures would continue to rise over the equator and decrease over the poles. So wind is directly correlated with helping move around temperature. So this is just an example of pressure, air pressure. So again, I use the one of having your hand and pressing against your desk. That is high pressure, okay? Now this is an important slide to understand. So all air has an amount of pressure that it is pressing against the Earth's surface, as I've already mentioned. Air that is, so we've got 2 different types of air pressure. We've got high air pressure and low air pressure. Air that has higher air pressure is sinking towards the Earth. So we say that high air pressure is heavy. That's a good way to remember it. high air pressure, the heavier it is, the closer it is going to be to the Earth's surface. Air that has low pressure is rising towards the sky. So low pressure equals light and will rise, like helium does when you put it in a balloon. So we can relate the H from the word high to the word heavy. So high is heavy, the L from the word low to light. Low is light and will rise. This is an important statement here. Wind is caused by air moving from areas of high pressure to areas of low pressure, which we're going to look at more in a moment. Why does air pressure vary around the globe? For two reasons. The heating of the sun and the Earth's rotation, the effect of the Earth's rotation. First, we're going to look at the heating effect of the sun. The warming influence of the sun varies depending on the time of the day. So temperatures are higher in the middle of the day than they are in the middle of the night. Temperatures are higher closer to the equator as compared to the north and south poles. We know that's because they're closer to the sun. As air heats, it expands and rises, which creates low pressure, which we just learnt about, so it's light. So hot air, it rises, so it's low pressure. Cold air, which is very dense, is a high pressure, so that stays lower to the Earth's surface. As the warm air over the equator rises and expands, cooler air from the north, from the poles, rush in to replace it. As a result, air is circulated around the Earth, and this movement of air is what we call wind. So I've got to think about it. This is continually happening. Air of a low pressure is rising, okay, and that's creating a gap underneath that closer to the Earth's surface. So air that's got a higher pressure, which is closer to the ground, comes in from all areas to replace that. And that's what we call wind. That's what creates wind. Now these are two really good images that help explain the effect of the sun on high and low pressure. So we'll just look at this one for a moment. So the heading is land heats up and cools down more quickly than the sea. So we've got our sea here and our land. So if we look at number 1 here, during the day, the air above the land heats up, expands and rises. So we know if air is heating up and rising, that's going to create low pressure and it's going up into the sky. So then all of a sudden we've got this gap on the land to fill. If we look at number 2 here, the atmospheric pressure above the land drops and the air moves in from above the sea, where the air pressure is higher. This causes a sea breeze or an onshore breeze. So the sun is going to heat the land up more than it is the ocean. So the air above the land is going to rise, which creates a gap to fill, which the air above the ocean comes in to fill. That's creating a wind in this direction, which is coming from the ocean onto the shore, which we call a sea breeze or an onshore breeze. And that's happening during the day. Now let's have what happens during the night. During the evening, the temperature of the land drops much faster than the temperature of the sea. So the land temperature is dropping faster than the ocean temperature. Look at number 4. The air above the sea becomes hotter than the air above the land. So it rises. Therefore, we've got a space to fill. So the air from the land comes in to fill this space, reversing the effect from this image. So the wind is going to be coming from this direction, from the land to the ocean. So it's an offshore breeze. Just looking at this box here, air that has high pressure is sinking towards the earth. So we're just reiterating, high pressure equals heavy. Air that has low pressure is rising towards the sky. Low pressure equals light and will rise like helium. Okay, so the second effect. So why does air pressure vary around the globe? We just spoke about the heating effect of the sun. Let's look about the effects of the Earth's rotation. The rotation of the Earth on its axis causes the air above the surface of the Earth to be deflected rather than to travel in a straight line. This causes the wind to circle around high and low pressure systems. The direction in which wind circle depends on whether you're in the northern or southern hemisphere. As the air moves from an area of high pressure to an area of low pressure, wind circles in the opposite direction in each hemisphere. In an area of high pressure, the wind circles in an anti-clockwise direction in the southern hemisphere and a clockwise direction in the northern hemisphere. This deflection of wind is known as the Coriolis effect. Okay, that's an interesting one and a little bit difficult to understand. So you don't need to stress if you don't understand that. We just need to understand that in the northern hemisphere and in the southern hemisphere, winds flow in different directions due to the angle of the Earth. Okay, so we're talking about air pressure. How do we measure air pressure? Meteorologists are able to measure air pressure, which they can do using a measure called a millibar. An instrument called a barometer is how we measure air pressure. Now this is a barometer here. My dad's got one at home very similar to this one, which is why I chose that. And you can see here, this is our indicator. It's a bit like a clock. And it actually gives you a bit of prediction of the weather due to the air pressure. So we can see here stormy, or there's a change coming, or it's going to be very dry. So they're fascinating instruments. So the average weight of air is about 1,013 millibars. Measurements higher than this indicate areas of high pressure, where the air is sinking. Measurements lower than 1,013 millibars indicate areas of low pressure. Here the air is rising. Now that concludes today's video. There are 3 terms that I would like you to add to your glossary. I hope you enjoyed this. I would love to hear your feedback. Please give me an email providing feedback on this video, and if there's anything I can do to enhance the quality of this video, please be sure to let me know.